Charts, graphs, numbers, percentages, data, data everywhere. Am I right? It can feel like you're drowning in it sometimes.
It really can. It's like we're bombarded with data from every direction.
Exactly. But what if I told you there's a way to make sense of it all? A secret decoder ring for understanding what those numbers actually mean.
I like that, a decoder ring. Now you've got me intrigued.
Well, that's exactly what we're diving into today. Levels of measurement. That's our key to unlocking the mysteries of data.
It's a fundamental concept in statistics, but it's surprisingly relevant to everyone, not just researchers or data scientists.
Absolutely. We'll be drawing on some amazing sources for this deep dive. Professor Bubblegum, the one who makes stats fun, and Bruce Frey, the best-selling author who's helped tons of people grasp these ideas.
They both do such a great job of explaining complex concepts in an accessible way.
For sure. Professor Bubblegum especially emphasizes that understanding levels of measurement has real-world applications. It's about making informed decisions in everyday life, not just crunching numbers in a lab.
I couldn't agree more. So ready to decode some data.
Absolutely.
Yeah.
Let's start with the basics. What exactly are levels of measurement?
Well, imagine you're a chef. You wouldn't use a teaspoon to measure flour for a cake, would you?
Oh gosh, no. That would be a disaster. Way too time-consuming.
Right. You need the right tool for the job. Levels of measurement are like those tools, but for data. They tell us what kind of information a number represents and what we can meaningfully do with it.
Okay, I think I'm starting to see the connection. But what are these different tools, so to speak?
Let's start with the most basic level, nominal. It comes from the Latin word for name, and that's really the key here. Think of it like tagging things with labels.
So, like, if we were sorting M&Ms by color, red, blue, green, we're not saying one color is better than the other, just grouping them?
Precisely. Or categorizing people by their favorite genre of music. You can count how many people like rock, pop, or country, but you can't say one genre is inherently greater than another numerically.
Okay, so far so good. Nominal data is all about names and categories, not quantities that we can do math with.
Right. With nominal data, the numbers assigned to each category are arbitrary. They're just labels.
Got it. So that's level one. What's next on this measurement ladder?
We climb up to the ordinal level. Here we introduce the concept of ranking.
So now we can say one thing is better or higher than another, but we don't know by how much.
That's the key distinction. Imagine a race, who came in first, second, and third. But the finishing order doesn't tell you the time difference between them.
This is making me think about those online reviews. Those star ratings for restaurants or products. A 4-star rating is clearly better than a 3-star one, but does that mean it's actually twice as good?
That's a great example. Ordinal data gives us a sense of order, but the distances between those ranks are unknown.
Oh, okay, so we've got labels with nominal and rankings with ordinal. What happens when we step up to the next level? Things are getting interesting here.
Now we enter the world of interval data. This is where things get really interesting.
Oh, interval data sounds mysterious. Tell me more.
Well, with interval data, we not only have order, like with ordinal data, but the distances between the points on the scale are meaningful and consistent.
Okay, so the intervals are equal. That sounds like a big deal. What kind of data falls into this category?
Think about temperature. The difference between 20 degrees and 30 degrees is the same as the difference between 30 degrees and 40 degrees. It's always 10 degrees.
Right. So those equal intervals let us do things we couldn't do with nominal or ordinal data, like calculate the average temperature for a month or see how temperature changes over time.
Exactly. That's the beauty of interval data. Because the intervals are meaningful, we can perform more complex calculations and statistical analyses.
But hold on a second. If temperature is interval level, does that mean we can't say that 40 degrees is twice as hot as 20 degrees? It seems like we should be able to.
That's a great observation, and it highlights a really important point about interval data. It lacks a true 0 point.
A true 0 point. Okay, explain that one to me.
So in the case of temperature 0 degrees Fahrenheit or Celsius, doesn't represent the complete absence of heat. It's just an arbitrary point on a scale.
Ah, I see. So even though the intervals are equal, we can't make statements about ratios or proportions when it comes to temperature.
Precisely. And that leads us nicely to our final level, ratio, which does have that true 0 point that we were talking about.
So like 0 weight actually means there's no weight at all.
Exactly. Or 0 income means you have absolutely no income. With ratio data, we can make those kinds of statements like this person earns twice as much as that person, or this object is 3 times heavier than that object.
Okay, I'm with you. Ratio data is like the ultimate level of measurement. It gives us the most information and the most flexibility for analysis.
You got it. However, for the purposes of this deep dive, we're going to focus mostly on nominal, ordinal, and interval levels. They're the most common, and they lay the groundwork for understanding statistical analysis in general.
That makes sense.
Yeah.
But how do we actually figure out which level applies to a specific variable? It can't always be as obvious as temperature or weight.
Right.
You're right. It's
Wow.
not always straightforward. Sometimes even experts debate the level of measurement for certain variables. Let's look at some examples from our sources to see how we can approach this.
Love a good example. Hit me with a variable.
Okay, how about this? You're conducting a survey asking people about their favorite type of pet, dog, cat, bird, or other. What level of measurement would that be?
We're dealing with categories here, not quantities. And we can't say one type of pet is more than another in a numerical sense. I'm going to go with nominal.
Spot on. Classic example of nominal data. Just labels for different categories.
Okay. Feeling pretty confident now. What about something like educational attainment? High school diploma, bachelor's degree, master's degree. Where would that fall?
Another great question. Now we've got a clear order. We can say that a master's degree represents a higher level of education than a bachelor's degree. But we don't know exactly how much higher, right? Like, is the difference between a high school diploma and a bachelor's degree the same as the difference between a bachelor's and a master's? Not necessarily.
Exactly. We have a ranking, but the distances between those ranks are unknown. That makes it a textbook case of ordinal data.
Okay. I think I'm starting to get the hang of this. Now, for a real brain teaser, what about something like happiness?
Happiness. That's a good one. It's often measured on a scale like from 1 to 10. Where would you put that?
Happiness from like 1 to 10. That's a tough one. There's definitely an order there. A 10 is way happier than a 1. But are those intervals really equal? Like, is the difference between a 7 and an 8 the same as between a 2 and a 3? I don't know about that.
You've hit on a key point. Variables like happiness, pain, or satisfaction, they often spark debate about their level of measurement.
Because it's all subjective.
Exactly. It's hard to say for sure whether those intervals are truly equal in terms of a person's experience. You can't really quantify feelings in the same way you can measure something like temperature.
So it's kind of in a gray area then.
You could say that in practice, though, a lot of researchers would treat this type of data as interval, especially if the scores tend to distribute themselves in a similar way to true interval data.
So we aim for the highest level, that makes sense. But we're also realistic about the limitations.
Exactly. And remember, the higher the level of measurement, the more sophisticated the statistical tools we can use.
It's all about choosing the right tool for the job, just like our chef analogy.
Precisely. So if we decide to treat happiness as interval, what kind of analysis could we do? We could calculate the average happiness score for different groups, see if happiness changes over time, or even explore how happiness is related to other interval level variables like income or hours of sleep.
Wow, that's pretty amazing.
Ah.
The level of measurement really does open up all sorts of possibilities for understanding the data. But how does this knowledge help us in our everyday lives?
Think about all the information we're exposed to every day. News articles, social media posts, marketing campaigns. They often use data to make a point or to try and persuade us of something.
Oh, I see.
Yeah.
So now I can look at those claims with a more critical eye. Like if a company says people who use this product are 50% happier, I can ask, hold on, how did you measure happiness? Was it nominal, ordinal, or interval? And did you use the right statistical analysis for that type of data?
Exactly. You've got it. You can start to see through the numbers and understand the thinking behind them. That's the power of understanding levels of measurement.
I feel like my data decoder ring is fully activated now. Huge thanks to Professor Bubblegum and Bruce Frey for their insights, and to you, dear listeners, for joining us on this data-driven journey.
It's been a pleasure.
We hope you've enjoyed this deep dive into levels of measurement. Remember, the key takeaway is that understanding how we measure things shapes how we understand the world around us. So go out there and decode those data points.